This one is a quick tutorial on wait, notify all methods of the object class in Java. Um, Consider this example in which you have thread 1 trying to execute this code, and thread 2 executing the same code here. Right, so T1 and T2 are executing the same piece of code, one after the other. Now, so when T1 executes this code, so T1 would obtain the log of obj and executes this code. And when it comes to this line of code, it would execute wait on obj, and obj has a log pool and a wait pool. Okay, so when T1 enters the synchronization block, it would obtain the log of obj, executes this code, and executes wait on obj and enter the wait pool of obj. Now, when it executes wait on obj, it would release the lock on obj. So when T2 tries to enter this synchronized block, it would, because the obj's lock is available now. Right, so T2 would gain the lock of obj, execute this code, and execute wait on obj. So that would make the wait pool of obj as T1 and T2. So both T1 and T2 are in the wait pool of obj. Now, if T3 were executing, now what should be realized here is the lock on obj is available because T2 has in turn executed wait on obj, which releases the lock on obj. Now T3 takes this lock and enters the synchronized block and executes this code and executes notify on obj. So when this happens, either one of these two threads would be moved to the log pool. Okay? But if you were to execute notify all on obj, then both these processes, T1 and T2, would be moved to the log pool of obj. Now, consider another example in which there is a queue. There is a jobs queue. This is the jobs queue. Oopsie. Right, and then there is a generator thread which would be trying to add tasks to the job queue, and the consumer thread which would be reading these tasks and processing them right here. Okay, now in this case, say for example, if consumer were to run before the generator, then this condition would fail because the remove task would throw a null pointer exception because jobs is empty initially. So in order to counter that situation, what you need to do is you need to have a condition check saying if you only execute the consumer thread if jobs queue is not empty. There is at least one job in the queue to be processed. And then you remove the task and you process it, right? But this one, if you notice, this one is in a while loop because it has to be. Because this one is written in a while loop. So if the generator were not to be ready, say for example in the first 5 minutes that the consumer was ready, then the consumer would be continuously looping through. Would be continuously in this loop, executing the same if condition. So you're actually wasting CPU cycles, right? So just to put things in perspective, say if my consumer started at 10 o'clock and my generator started at 10:05. From 10 until 10:05, my consumer would be coming into the while loop, making a condition check, which would be false, and then this sort of, it repeats, on and on for the first 5 minutes. So thereby you'd be wasting CPU cycles, and this is called spin waiting. Okay, now how do you counter that problem? So what you could do is you could use, instead of spin waiting, what could be done is you could use some event mechanism, in which you let the threads communicate. You let the generated thread as well as the consumer thread communicate using the notify and wait methods, right? So yeah, you so once the consumer comes in, it actually okay, so it should be in a synchronized block, and so is the case here. Should be in a synchronized block. Okay, so the consumer thread would get the log of jobs, right? And then it would, because jobs is initially empty, it would wait until it is notified. Now when the generated thread um, uh, gets a log on the jobs, it would add a new task to the job and notify it, thereby making the consumer thread operate on the job that has been added on the queue.